You ever look at something totally ordinary, like the plywood in your furniture, and wonder, could this be better? Well, it turns out it can. A lot better. Today, we're diving into some really cool research that shows how a clever little tweak to a glue recipe made plywood not just way stronger, but also a whole lot safer for our homes.
All right, so this right here, this single image pretty much tells the entire story. By adding an additional strong acid step at the very beginning of the normal glue making process and, using more concentrated ingredients, these researchers created a final product that was both stronger and less toxic. So how on earth do they crack a problem that's been bugging the industry for years? Let's break it down.
So, first things first, we've got to understand the core problem, the big dilemma with the glue that's in most of the wood products we use every single day.
And we are talking about a massive, massive scale here. Urea-formaldehyde, or UF resin, is basically the go-to glue for things like plywood and particle board. Why? Well, it's cheap, it's effective, and we use about 11 million tons of it every year. But it has a pretty serious downside.
And that downside is formaldehyde. Yeah, that stuff. It's a key ingredient, but it's also a toxic chemical. And over time, it can get released from wood products into the air in your home, a process called off-gassing. And that is a real health and environmental concern.
So here's the crucial point, this really frustrating trade-off. The obvious solution to cut down on toxic fumes is to just, use less formaldehyde in the recipe, right? But whenever manufacturers try that, the glue just doesn't hold up. The bonds get weaker, the panels aren't as durable, and the product quality just tanks. For years, it's been a choice. You get safety or you get strength. You couldn't have both.
Now, to really appreciate the breakthrough, we have to take a quick look at how this glue is normally made.
Okay, so the industry standard is what they call the alkaline acid process. Think of it like a two-part chemical dance. First, you mix the main ingredients in an alkaline or basic solution. That gets the first few molecules to start forming. Then, you hit it with an acid, and that kicks off a reaction that links everything up into these long, sticky polymer chains that make up the glue.
And this graph shows that process perfectly. See the top one? The red line is temperature, but let's focus on the blue line. That's the pH. You can see it starts up high in the alkaline range, around a pH of 8. That's step 1. Then, boom, about halfway through, they add the acid, and the pH plummets to around 4.5 to finish the job. Remember what that looks like.
Now, for the fun part, the innovation. Researchers started thinking, what if we just flipped the whole thing on its head and started with a really strong acid instead?
The idea was to jam a brand new step, a strong acid step, right at the very beginning, before the traditional process even got started. Now, people knew this could have some big benefits, but it was also notoriously difficult to control.
And here's why it was so tough. In a strong acid, the chemical reactions go crazy fast, and they generate a ton of heat. If you don't get the conditions exactly right, the whole batch can just instantly seize up into a solid, useless block of gel. And sure enough, the researchers' first tries were a total failure for exactly that reason. The mixture either separated into layers or just turned into a big lump.
So let's compare the two side by side. The top is the standard process we just talked about. But look at the bottom graph. That's the new way. Look at that blue line. Right at the start, they drop the pH all the way down to 1. I mean, that is highly acidic. They do that for the initial strong acid step. Then they neutralize it and carry on like normal. This initial shock to the system, well, it turns out it's the key to everything.
So, they figured out how to control the reaction and make a stable glue. Awesome. But then they immediately hit another huge wall.
The new glue they made was stable, which was great, but it took an incredibly long time to actually harden, or gel. We're talking 258 to 282 seconds. The normal stuff? That hardens in just 35 to 50 seconds. In a factory, that kind of delay is a complete non-starter.
So, what was the fix? It actually turned out to be surprisingly simple. Instead of using the standard 37% concentration of formaldehyde, they just tried a more potent 50% solution as their starting ingredient.
And that was the big aha moment. This tiny change completely rebalanced the chemistry. It gave the resin the kick it was missing, and it brought that gel time all the way down to just 28 to 34 seconds, even faster than the original. So now they had a recipe that was stable, practical, and ready to go.
Okay, this is where it gets really, really exciting. They had this new recipe, but the big question remained, did it actually solve that fundamental trade-off between strength and safety?
Let's look at the data. Could this new glue really be both stronger and safer? Well, the results were, frankly, they were staggering.
Now check out these raw numbers. This chart shows the internal bonding strength, basically how well the glue holds the layers of wood together. The standard resin, that's on the left, it averages about 1.25 megapascals. But the new modified resin on the right, it comes in at an average of 2.36 megapascals.
That is not a small jump. It is almost twice as strong. Think about that. You could potentially use less glue and still get better performance, which saves both money and resources. So it's stronger, but is it safer? Well, this table lays it all out. These are the results from the emission test. The standard resin gives off about 26.69 milligrams per liter of formaldehyde. The modified resin? Just 15.21. That is a 43% reduction in toxic emissions. They didn't have to weaken the glue. They got a massive improvement in safety while almost doubling the strength. They absolutely shattered that trade-off.
And the researchers themselves said it best in their conclusion. They wrote that with this new process, you can get lower formaldehyde emission without having to sacrifice bonding strength. I mean, that is the holy grail for this entire industry.
And that leaves us with a really fascinating thought, doesn't it? This was a huge leap forward for a material we see every single day, and it all came from just rethinking the very first step in a recipe that's been around forever. It really makes you wonder, what other breakthroughs are just hiding in plain sight, waiting for someone to try one simple, clever change?